Okay, so this is our Chapter 7 quiz review. It's a shorter chapter. 7.4 covers simulations, which requires a more advanced calculator than the one that we are actually using this year. We may end up revisiting that. I just have to figure out a way to get us access to calculators or a lab. So for now, we're just going to focus on the probability part of the chapter. And so it'll cover the three sections that we've already covered. So first section we need to be able to answer, describing likelihood. Go ahead and use the words that we learned in class, on that scale of probability, and describe the likelihood. Don't write the phrases, please. Just describe the likelihood. All right, since we're working on our desk today and we're writing everything. All right, so let's describe our likelihood. 10% chance of rain, guys.
Unlikely.
Yeah, definitely unlikely. Okay, that would be unlikely. And then I thought I had written that. Hold on. So unlikely and 50%. Equally, not 3 L's. Equally likely. All right. Okay, let's talk experimental probability now. Okay, let's answer the first one together. You randomly draw a marble from a bag, record its color, and then replace it. Draw a blue marble 3 out of 50 times. What is the experimental probability that the next marble will be blue? Okay, so for experimental, remember you have to write probability and what you're going for. Probability that the next one will be blue. Well, I take the past successes, which was 3 out of 50. Okay, now, the way I taught you is to do the division. However, I know a percentage is out of what? 100. Can I easily make my denominator 100? What could I multiply my denominator by to make it 100? 2. So if I did 3 times 2, I would get 6, which is my percentage. All right, so I had a couple people in the last class actually catch on to that a percentage can be out of 100. So I know if it happens 3 times in 50 tries, I can just double it to make 6, and it would be 6%. All right. Otherwise, you can just divide and change it to a percent. Okay. All right, so now I'm making a prediction. I almost wish that the predicted amount wasn't 100 because it makes it a little easier to solve. But you're going to use the table. The table is not the 100 attempts, okay? So you need to calculate the probability based on the results of the table and then multiply that probability times the future total. This is where we use the relative frequency in our notes. Okay, so find your probability and then take that to multiply it by your future total. Go ahead and work on that. So I know, how many times did I spin a 4 in the table? 7 times. So the probability I spin a 4 is 7 out of 50. This right here, this total down here was only spun 50 times. So I know if I spin it 7 out of 50 times, okay, 7, that's a 14%. Now, it's 100, so again, you could do the same method that I just explained to figure out how many it would be in 100, but let's assume for a minute you don't do that. You can use your percent equation to predict A equals P, your percent, 0.14, times whatever that future amount is, and that will give you the prediction, okay? So use the table to predict the number of times. Well, if I spin it 7 times out of 50, that means I would spin it 14 times out of 100. Okay? All right, do you see that? Do you see how I got that? I used the probability to predict a future amount. All right, so that's experimental. Now let's do theoretical. Find the theoretical probability. Remember, you should have something in parentheses, probability of this. Okay, and then try to solve it.
Does this assume?
Okay, theoretical. So experimental says it actually happened. Theoretical is this has not happened yet. Okay. All right, guys. So probability of what? Probability of yellow. Probability of yellow. Okay, is 7 out of what? Wait, where'd you get 17?
You add the two together.
Okay. Yes, you add them together. All right. Anybody get 41%?
I got 41. What if you got 41?
Okay. All right. 41%. Okay. So we're going to do comparing now. So the bar graph shows the results of spinning a spinner 100 times. We talked the other day about person who gets obsessed at Chuck E. Cheese and just stands there and like does one game 100 times. Okay, so anyway, so you spin it 100 times. The bar graph shows those results. Give me the experimental probability of spinning an even number based on the bar graph. Then I need you to find the theoretical probability of spinning an even number and compare them. All right, so I'm going to walk around and kind of help you guys out, or if you get stuck, go ahead and work on this in your groups. Okay, so how many even numbers are in the bar graph?
There are
2 and 4. So I did a 2 18 times and a 4 21 times. So what's 18 plus 21? 39. Okay, which is 39%. Now, the one thing I forgot to write is probability of the even, so P parentheses even. I should have done that, okay? So now theoretical says how many even numbers are there out of the total number of numbers? There are how many even numbers, guys? 2 out of how many? 5. So for 2 out of 5, that's a 40% theoretical probability. How did I get 39%? Because I added the number of outcomes for 2 and 4. Okay, so again, I should have written probability that it's even. Okay, is 40%. So how would you compare the two? How would you compare them, guys?
Equally like.
Yeah, they're very much. I would say it's almost the same. Because basically what you're saying is their percentages are very close to each other. That it's almost the same. Now, can anybody tell me potentially why my probabilities are so close together? Matthew?
I didn't raise my hand.
I know, but I heard you saying it.
The more you do it, the more accurate it gets.
Yes, the more you do the experiment, the closer that probability becomes to theoretical. For example, is there a chance if you were to only spin the spinner 10 times, is there a chance that you would have spun an odd number 10 times in a row?
Yeah.
Yeah, absolutely, there's a chance, okay? But is there a chance that you're going to spin the spinner 100 times and land on an odd number every time?
No.
No, I mean 100 times, you're going to land on some even numbers, okay? So the more times you spin it, the closer those probabilities come to each other, okay? All right, do a tree diagram. Remember, you want to start with the category that has the fewest options, okay? So you choose between red, blue, yellow, green wallpaper, and purple or yellow carpet. I didn't make this problem up. Whoever did definitely does not have any fashion sense. Okay? So find the total number of possible outcomes when you select one of each, okay? So don't worry that it's not like you can pick 2. I know. All right, so how many categories do I have?
2.
I have 2 categories. Which one, wallpaper or carpet, has the fewer options? Okay, yes, carpet. Okay. Huh?
So do you go fewer to more?
Yeah, you start with carpet. What are my choices for carpet?
Purple or yellow?
Purple and yellow.
Red.
Okay, and then in my second column, I'm going to go wallpaper. Okay. All right, go ahead and try to finish your second column. Start writing them. Red, blue, yellow, green. Okay, so I can go all these, or I can go yellow, and then I could go red, blue, yellow, and green. Okay, so, right, yeah. Okay, so now here's all my outcomes. Yeah, I'm just going to abbreviate, okay? So purple, red, PR, PB, PY, PG. Purple, blue, purple, yellow, purple, green. Can you imagine? Okay, then it could be yellow and red. Hey, let me ask you this. Okay, I technically don't. No, wait, I don't have a yellow red. All right, let me keep going. Yellow, blue, yellow. That would be interesting.
That's like my least favorite color.
Yellow, green. Okay. I thought I was gonna have combination that was opposite, but I don't. Okay, so how many outcomes do I have?
Yeah, a lot.
I have 8 outcomes, but I can see specifically the different options. Okay, so I could ask you something like this. Listen, guys, this is important. I could ask you a question like this. I could ask you, how many of these outcomes would not involve the color yellow? How many of these outcomes? So give me the probability.
Three.
I see 3. Okay, I would say something like this. What is the probability that yellow will not be a color in the room? And you would say 3 out of 8.
It's 25.
3 out of 8.
I don't get before. How?
I don't see. I see purple, red, purple, blue, purple, green. It's only 3.
1, 2, 3. Yep, 3.
Okay, so we can calculate probability from this, guys. All right, let's do the fundamental counting principle. We are running out of time, so we'll just do the first one. They're both this. Actually, we'll just do them both. We just need to do them quickly. Okay, fundamental counting principle is much faster. All right, go ahead and work these 2. Okay, so what did you do, guys?
Multiply
6 times 8 times 3 to get
144
outcomes, combinations. You want to do a tree diagram for that?
No.
Oh, no. Okay. What about the next one? 90.
I got that.
90. 90 combinations. If you said 90 outcomes, 90 whatever, as long as it's some label. Okay, probability of a compound event. Remember, guys, on this one, it has to have both outcomes have to happen in order for it to be favorable. Okay, so both outcomes have to happen. It says you roll a 6-sided number cube and flip a coin. What is the probability of rolling a number greater than 5 and flipping heads? So I've got probability in parentheses, and then I'm going to have a fraction, and then I'm going to have a percentage. Try to fill this in. This will be our last problem. What did you write in parentheses?
6H.
Number greater than 5 and heads. Okay, so on a 6-sided number cube, how many numbers are greater than? My only option is 6 heads. That would be favorable, which is one favorable option. Wait a second, but it doesn't tell me the total. You don't add.
It's a 6 number.
Fundamental counting principle. How many options on the cube? 6. How many options on the coin?
2.
What's 6 times 2?
12.
1 out of 12 would be approximately What percent?
60.33.
Yep, it's about 8%. Okay, so what you need to remember is they're not going to give you 12 on the compound events. You have to use, usually it's going to be fundamental counting principle. What now? Okay, all right, 8%. That's everything you need to know for your quiz review. We'll do a separate one for your test review.